Hey everybody, this is your pre-cal video on 4.2. We're doing the real zeros of a polynomial function. So your objectives are to be able to use the remainder and factor theorems, the rational zeros theorem to list the potential rational zeros. This is actually the part that students don't like that much because you can't just use your calculator and say the actual, but you need the potential. So you're going to have a lot of potential zeros. For example, like what's listed. Find the real zeros of the polynomial function. Use the calculator if you're able to round, or use factoring or the quadratic formula. So you have a couple of different methods to use. The theorem on bounds and the intermediate value theorem, where you can say if you have 0, -5, and 3, 1, notice one of these y values is negative and the other is positive. And so that meant that the y value had to cross 0 if it was continuous. And so there had to be an x-intercept. And so the x-intercept would be between 0 and 3 in this case. Okay, so again, in section 4.1, we were able to identify the real zeros because it was either in factored form or could be factored easily. But how do we find it if it cannot be factored that easily? So you'd have to use what we call the division algorithm. Algorithm just means steps. So F is on top, that's the dividend. Q is your answer, which is the quotient. G is what you're dividing by, so think of it as that. Dividend is the top, divisor is the bottom. The remainder would be right there, the R function, and you have to put the G thing on bottom as well. And if R is 0, then it's factorable. So as an example, I say x minus 3 divided into x squared plus 2x minus 6. Be careful about placeholders. Use 0 as a coefficient if there's not a term. So your answer would be in the format whatever your quotient is plus your remainder over x minus 3. And I say do that with long division and synthetic. Okay, so with long division, we have x squared plus 2x minus 6. Remember that if we didn't have an x term, we'd have to put a 0x there. And then we just work it. X times x is x squared. X times -3 is -3x. Now, since it is long division, we got to subtract. And so that would make these cancel. And when you're subtracting, we don't usually put this minus, but this would change from minus a negative, so positive 5x minus 6. And then we'd have to put a plus 5 for the front one to match, which is always our goal. And then that cancels, and minus a -15 means plus 15, so we get 9 for our answer, for our remainder. So we'd say x plus 5 plus 9 over x minus 3. So that's how you do that. That's with long division. With synthetic, you got to change your sign, and you're going to add. So even if it's x minus 3, you have to put 3 because x equal 3 is what we were looking at. And then you got to do 1 for your coefficient of x squared, and then a 2 and a -6. So then you draw your line, bring this one down. 3 times 1 is 3. So notice you multiply this way and your answer goes there. and you add, so 2 plus 3 is 5, 3 times 5 is 15, so that answer goes there, and negative 6 plus 15 is 9. Now what I always do is I block it off a little bit and I put equal r, so that tells you x plus 5 and then plus 9 over x minus 3. So exactly the same thing we got with the long division. So with synthetic, all you do is use coefficients and you add. With long division, you use x's and you subtract. Okay, the remainder theorem is if it's divided, then your remainder would be f of c. So if I did f of whatever the remainder is, then it would work out. So if I did f of 9 on this one, I could see what my part is. There's a factor theorem that says x minus c is a factor if and only if f of c equals 0. So if there is 0 remainder, then it's a factor. Also, while we're on this, remember the IFF is the shortcut for if and only if. So this factor theorem does work both ways. If f of c is 0, it's a factor. If x minus c is a factor, then f of c is 0. So that's working both ways, like in geometry proofs and statements like conditionals and converses, that stuff. Okay, next we have the theorem of, or on the number of real zeros. You can't have more than the degree, and so if it's x cubed, it has at most 3. But it could be 1 real and 2 imaginary, because there's a conjugate pairs theorem that the imaginary ones have to go together. There's a rational zeros theorem, which is when this is in lowest terms, it's a rational 0, and then p has to be a factor of a0 and q for an. You have some steps. Use the degrees to determine the max number. If it's integer or whole number coefficients, use a rational zeros theorem. For potential zeros, then graph them to find the best to test or eliminate. Use your factor theorem to determine if the potential one is a 0. If it is, use synthetic or long. Again, long uses subtraction, synthetic uses addition. Each time that a 0 and thus a factor is found, repeat the steps on the lower term, like the lower exponent equation. When it says depressed, it means like from x cubed it went to x squared. And if you did with x squared, then it'd be x, and so forth. When you're attempting to find your zeros, remember to use the factoring techniques like special products, factor by grouping, and so forth. Now, there are times where you're going to have linear factors and or irreducible quadratic factors. Those are quadratic factors that can't be reduced. And I'll show you a few examples of those when we get to it. The corollary to the theorem, or just the extra part, is if you have odd degree, it has at least 1. Now for your bounds on zeros, this is the part that the wording is always very, very weird, and it's tricky. It's the smaller between two numbers. One of the numbers is this max, and the other number is this 1 plus the max. So you do both of those, and then you pick the smaller one. And this one is just a sequence. Like, what's bigger, 1 or this addition stuff with absolute values, or is it 1 plus the max of this, between 1 and those. I'll show you that, but the part that y'all get confused on sometimes is it the larger one? No, it's the smaller. So that would be, because you want the smallest window for it to show up. So then notice the sum on the first max, the commas on the second. If the sum is higher than 1 on the first one, then use the sum, otherwise 1. On this one, choose which term has the highest absolute value, and then add it to 1, and then choose your smaller bound. Choose your smaller one between those two. For the intermediate value theorem, again, we have to be continuous, and then if there's a change in sign, then there's something that happened. And there is an example video that I have a link of on long division versus synthetic. Okay, so that's 11 minutes. Let's go ahead and start the problems now. So this says, use the remainder theorem to find the remainder when f of x is divided by x minus 1/3, then use the factor theorem. Okay, so what we're first going to do is I'm going to have long division 3x to the 4th minus x cubed plus 0x squared, don't forget that, plus 6x plus 2. And for those that are going to try it the other way, you're going to have to do 1/3 and then do 3, -1, 0, 6, 2. So again, don't forget the 0 term. Okay, so with long division, we want this to be 3x cubed for it to match. So then this one cancels. And then you go 3 times -1/3 is -1. So this is -x cubed. So again, when we do minus a negative, that cancels. And the 0 would also cancel. So it's like plus 0x squared plus 0x. Now we finally have the plus 6. And when we do 6 times x, that's 6x. And when you do 6 times -1/3, you get -2. So this is where it's like, it kind of looks like an optical illusion, whatever. This one cancels, but this one's minus a negative, which really is 4. Don't accidentally put 0 there, because if y'all weren't thinking about this little minus sign, you say 2 minus 2 is 0. So what is he doing? Oh, well, it's understood to be minus. So minus a negative. It's plus. Okay, so that, again, is long division. Synthetic division is this, where you bring down the 3. Then we say 1/3 times 3 is 1. Add, and you get 0. Multiply, you get 0. Add, you get 0. Multiply, you get 0. Now we do 6 plus 0 is 6. 1/3 times 6 is 2. And 2 plus 2 is 4. And then I do my little thing where I call this the remainder. This is the number term. There's a 0x, there's a 0x squared, and there's a 3x cubed. So then we would just write it as 3x cubed plus 6 with remainder 4. So like that. 4 over x minus 1/3. Okay, so all that to say, 4 is a remainder, and it's no. It would be yes if the remainder was 0. So if you actually got a number other than 0, then this is a no. All right. Now on this one, we have to do our rational zeros that are potential zeros. And on this one, we have to do the stuff with the P's and Q's. Before I actually do this one, I just want to go back. So when I, in 2018, did my book notes from doing the problems, these look all similar to what we've done. So in this one, I got a number, and so that was just like true false type questions. If you get 0 for the remainder, then it is a factor, and we can also call that a solution, root, or 0 of the graph. Okay, now on this end, this is where we started doing synthetic or long division, and if you got a number other than 0, then it was not a factor. Now, when we're to the part where it says determine the max number of zeros and list the potential, that's the part where you got to think of Q being the first and the P being the back. So that's what I'm going to do here. I'm going to say Q is the front, so negative 25, and P equal 5, which is the back. And what we want is P over Q. Need P over Q. Okay, so on this particular one in the book, I had Q was 2 and P was 1. So I had to do factors of 2, so that's basically plus and minus 1 times plus and minus 2. So like 1 times 2, negative 1 times negative 2. So those were my factors. And to get 1, it was plus and minus 1. Because you could say 1 times 1 or negative 1 times negative 1. Then once you do that step, then we need to do P over Q. And so you do 1 over 1, 1 over 2, and you actually do plus and minus with that. And then, well, that just simplified to plus and minus 1 and plus and minus a half. So in the same way, we do one like this, where we had Q is negative 4, P is 6. List out your factors, and then start doing P over Q. And what I did was I said all the ones divide by 1, then all the ones divide by 2, all the ones divide by 4, etc. Okay, so let's go through that process on these. So to get negative 25, we could say 1 times negative 25. We could say negative 1 times positive 25, or we could say 5 times negative 5. So how I write that is I say plus and minus 1, plus and minus 5, plus and minus 25. So those are my factors. And then for P, we have 5, and so that'd be 1 times 5 or negative 1 times negative 5. So I say plus and minus 1, plus and minus 5. Now we need to do P over Q. And so when I say my Q values, are going to be divided by 1, divided by 5, and divided by 25. This is basically P divided by Q, Okay, so for the divide by ones, I have a p that's 1, so I can do 1 over 1. Let me cross this colon out. 1 over 1, negative 1 over negative 1. I mean, never mind. You could say 1 over 1, you could say 5 over 1, which is 5, and you can say, well, it looks like those are the only ones. So you have 1 and 5 for that one. Now for this, we want 1 over 5 and 5 over 5, which is 1, which was already listed. Let's start making a running list of them. So one of them was 1, another was 5, another was 1/5. We don't have to do this one over again. Okay, so for this one, we do 1 over 25, and we do 5 over 25, which is really 1/5. So the 1 over 25 was not listed yet. Okay, so then this is what I like to do. I say 1, 2, 3, 4 terms. Notice these should all be plus and minus, and so now it's 8 terms. And if you want to list them in their order, actually I'm in a good order right there. I got my 1s, I got my 5s, I got my 1/5, positive and negative, and my 1/25, positive and negative. So that's how that works. All right. Now, if we took it one step further and just said which ones were actually the zeros, you just graph it. So you have 8 potential zeros, but you could have fewer than that are actual ones. Okay. Actually, I'm not going to attempt to find the zeros because that's going to take more time. Okay, so let's do this part now. We call the Q to be 6, and we call the P to be 20. Mind your P's and Q's. Okay, so how do you do your factors? Well, this would be plus and minus 1 times plus and minus 6, and plus and minus 2 times plus and minus 3. Now, on this one, you do plus and minus 1 times plus and minus 20, plus and minus 2 times plus and minus 10, and plus and minus 4 times plus and minus 5. Okay. So now we need to do our P divided by Q, and for my Q's I'm going to need to say divided by 1, divided by 2, divided by 3, and divided by 6. So those are my Q's. So now I need P divided by Q. So 1 divided by 1 is 1, and so that's in our list. I do 20 divided by 1, and that's 20. I do 2 divided by 1, and that's 2. I guess I'm going to wait on my list. I do 10 divided by 1. I do 4 divided by 1 and 5 divided by 1. Okay, now what you can tell about all your multiple choice is they are going left to right numerically, and so I'm going to go ahead and say 1, 2, 4, 5, 10, 20. Okay, well, y'all are lucky it's multiple choice, because I can see even by just doing that there's no 3s. And so I know it can't be A or B. Okay, for this one, you got a long answer with all these and a shorter one. When we do divide by 2, we're going to do 1 divide by 2, so a half. We did 20 divide by 2, which is 10, which is already listed. We do 2 divide by 2, which is 1, which is already listed. We do 10 divide by 2, which is 5, which is already listed. We do 4 divide by 2, which is 2, which is already listed. And we do 5 divide by 2. So right there is the key, because I can see that this one and this one are the only ones that have 5 over 2. And since we already ruled out the first choice, and we're now ruling out the bottom choice because it doesn't have 5 halves, that should be pretty good confidence on what we need. But let's still continue. On 3, we need to do 1 divide by 3, so that's 1/3. 20 divide by 3, so that's why that one showed up. 2 divide by 3, so that's why that showed up. 10 divide by 3, which is why that showed up. 4 divide by 3, again, that's why that one showed up. And 5 divide by 3, which is why that one showed up. So now we can add, we have 1/3, we have 20/3, we have 2/3, we have 10/3, we have 4/3 and 5/3. So we already have a lot of terms before we even get to our divide by 6. Now on the divide by 6, I need 1 divide by 6, so that's why it's 1/6. I need 20 divide by 6, which is really 10/3, and we already listed that. 2 divide by 6 is really 1/3, and we already have that. 10 divided by 6 is 5/3, and we already have that. 4 divided by 6 is 2/3, and we already have that. And 5 divided by 6. Oh, this is the first time for that. So there's 5/6 and there's 1/6. Okay, so there you go. We have now got these potential zeros in a list. I'm going to stop that video right there because I don't think number 4 is the same way. No. I'm going to stop that video and then I'm going to start the next one. I hope that helped.